Section 8, Sketching with Derivatives. Thankfully, this is a pretty easy section. So, I'm just going to do an example here and to walk through how I think about these. So I'm actually going to start with the second one because it's easier. So let's look at these lines. They have a slope of -1 at the start here. So that means our derivative graph is going to be down here at -1 until it reaches that point, at which point there's a hole. That's a cusp. So it's discontinuous there, so I got to put an open circle. Then I'm going to come up here. The slope is now 1, open circle. My line goes along here until it reaches here, another cusp. Now we switch to a, oh man, what is this slope? It's going down 2 for everyone, so it's -2. So we're just going to go boom down here and all the way over to our next cusp, another open circle, and then here we have a slope of actually +1/2. So there. So notice our derivative graph kind of looks funky, like down, up, down, which makes sense from the graph. All right, now let's come over and start sketching over here. This is one where we can't know exactly, because here we do the slope exactly by counting boxes, and here this is wonky, so give it our best effort. So here we start off, our graph is going down, so we're going to start off with a negative slope that's getting less steep. So it's going to start off here and go there to 0. Then it goes up for this whole time, and then it goes down to 0 again here, and then it goes back over. Now if you remember when we've talked about derivatives of sines and cosines, they're the derivative of each other. Yeah, it's just off by a phase. It looks like a sine wave just shifted over a little bit. This is the start, it goes down, it goes up, just like this one. Alright, next section. This guy is going over 1 and up 1, so at this one we actually know. We can go, so open circle down here, because we have a discontinuity. Open circle up here at 1, which I kind of whiffed on, and go through there, and cool. So that we got that section down. All right, now this, we're starting off kind of less steep and then getting more steep, but everything is negative. So we're actually going to come down here and just get a little bit more steep. So I did something like that. So steep slope, more steep. And for our last section, we're back to our sine wave. We start off at 0 slope because it's flat there. And we're going to end up at 0 again here. So I can actually put dots at all the spots where it's 0. This can be a good thing when you're learning how to do this, is to just put dots at those. And then just connect through. Here we have a negative slope because we're going down. So we're actually going to just do one of these. Positive slope. So back up, back down. And that's it. There are multiple types of problems I could ask in this section. I also could ask about the intermediate value theorem. So let's talk about that real quick. The intermediate value theorem was covered in another section, but it could be asked here because this is a applicable time to ask for the question. So intermediate value theorem is just the whole idea where you have a graph and you have 2 points. And let's just make these do something on the other side like that. And now, what the intermediate value theorem says is you have to go through all of the y values here in order to connect these points if your graph is continuous. So if you say your graph is continuous, that means you can't pick up your pencil when you start at one point and you got to connect to the other. It's got to go through all the y values in between. And that's it. That's all that's in this section. Good luck.